Right, so in the second part of addressing ionic bonding and these practice problems here, we're going to determine the number of atoms for each pair of elements here that would be needed to create a neutral ionic compound, and then writing the answer as a molecular formula. So in the previous examples up here, this is exactly what we did for step 5, where we're just determining how many of each atom is needed to cancel out and create a neutral compound. However, as much as we love drawing the valence shell diagrams every single time, it's actually not necessary. It is great when you're first learning. However, you can actually take a shortcut if you have the annotated periodic table and answer the question that way. So basically what we're looking to do in these problems is determine how many electrons would be lost or gained for each atom, and then determine the number of cations to neutralize those anions. So if we start out with lithium and fluorine, if we're looking at lithium, it falls into group 1. And we've got, so if it falls into group 1, it essentially needs to get rid of one valence electron, right? And if it's getting rid of an electron, it is becoming less negative. We automatically know without drawing the valence shell that it has a +1 charge. On the other hand, fluorine, we know it's going to gain 1 electron based on this chart. Okay, it needs 1 more electron to fill up the valence shell. Because of that, we know that gaining an electron will create a charge of -1. So we know that it will take 1 lithium atom and 1 fluorine atom to form this neutral compound at the end. So this is nothing new, right? We did this in some previous practice problems. Now we're just skipping the drawing of the valence shells and thinking directly about the charge. So we did that first example. I want you to try these other problems, pause the video, and we will look at these answers in just a moment. Now moving on for the sake of the video, lithium in the second problem, right? We've got a +1 charge. Oxygen has a -2 charge if it's taking on 2 electrons. How many +1s do we need to cancel out -2? 2, right? So we've got this Li subscript 2, oxygen. And of course, we have the cation or the positive listed before the anion, which is the negative atom. And here we actually mix it up a little bit more. So as we know, lithium has to ditch an electron, so it ends up with a +1 charge. And we have nitrogen. So nitrogen actually needs to gain 3 electrons to get that full valence shell. And that aligns here, right? It's in group 5. So it actually takes 3 lithium ions to neutralize that nitrogen. So here, or actually here, so this is supposed to be line 3. And in Word up here, if you're wondering how to do a subscript, it's actually up in the formatting on this home tab. So Li3, nitrogen. Got magnesium chloride. We actually already covered this in the top, but if you want to try it again using this method with the periodic table, go for it. We've got magnesium and sulfur together. So magnesium actually has to get rid of 2 electrons and sulfur has to gain 2 electrons. So that +2 and -2 just cancel each other out. We've also got phosphorus here. So this one's a little different. So we've got the magnesium with the +2 charge, and we've got the phosphorus with the -3 charge. And this involves a little like common denominator work actually. So the common denominator here would be 6, right? That's what they're both easily divisible to. And so if we have 3 magnesium, that would give us a charge of +6. And if we have 2 phosphorus, that would give us a charge of -6. And so those would cancel out to create our neutral compound. And for this last one, we have potassium, which has a +1 charge. It's getting rid of 1 electron, and oxygen, which needs to gain 2 electrons. And so because of this, you would actually have 2 potassium atoms bonded to 1 oxygen atom. So just cross-reference your answers with mine. Make sure that you understand this process. And I'm actually leaving problems 8 and 9 to be addressed in the Unit 1.2 homework. So if you have been working through these, 8 and 9 should be a piece of cake. And that about wraps it up for ionic bonding. The next type of bonding in the next video we'll talk about will be covalent bonding.